Hello everyone. 12:05. Nothing's crashed. I think we might have some success today in getting off at the right time. Hope everyone's been well, and super excited to get back into it. So we're going to start where we left off yesterday. A quick recap. So yesterday we had some welcome and introductions. We talked about our course admin and talked about where to get help as well. We talked about how COMP1511 works and where we... Oh, I am right on top of what's going on. I'm sorry. Let me move myself. It's not really that important that you see me on camera. So... There we go, that's better. Okay, we also talked about the best approach to learning programming. We talked about what is programming, and we also talked about what is Linux and working in Linux. Then we kind of started going over our first look at C before it changed to 12 o'clock and my computer decided it had had enough and just kind of crashed and burned. So hopefully we can now come back to that program. I know that a few of you would have gone off and done a lot of that sort of introductory hello in your labs yesterday. So, yep, let's talk. Let's talk about the progress. Sorry, I just saw someone comment if there's an audio and I thought, oh, everything I've talked about is now missing. Okay, what we're going to talk about today. Today is going to be a super exciting day. We're going to do a quick hello.c and then we're going to get into it. We're going to talk about some variables. We're going to talk about how we're storing them, maybe some maths in C because who doesn't love maths on a Wednesday? And then we're going to talk about conditional statements. So running our code, that should say our, not out. Running our code based on some sort of condition being met or us asking some sort of question, and based on the answer we're going to run a particular piece of code or not. So we're going to talk about if statements and how they come together to give us more flexibility in our code as well, and choosing what code we want to look at. Okay, also when we do code in the lecture, you can find it on this link. So any live code in the lecture will also appear in here, which means that you can, work alongside us in the lecture, or you can look at what we're doing. So every time I save, it will update at that link. And you should hopefully be able to see that piece of code. And that's really, as we go onwards to the subsequent weeks, the code will get a little bit harder. There's going to be a little bit more code. So sometimes you might miss something that I've said. You might want to just update your code from that, but it also allows you to go back and have a look at what the code looks like that we've done in the lecture. Okay, let's have a look at what we started discussing yesterday. So yesterday we started to look at our first program. It was hello.c or whatever you want to call it. It really doesn't matter what we call it. And this is really, your hello world is the standard way to introduce you to almost any programming language. And so basically, we've got a little piece of code here. This one will print out into the terminal, and we will look at it in a second, what it will print out. So we've got up the top in blue, we've got our lovely header. And I think, yes, I went into it. So the little header, the header is for humans to read. Remember that anything with two slashes is something that the compiler just skips over. It says, this is not for me, this is for a human. I don't want to read things that are for a human. And basically what it does is that it gives a little title of what the program is, perhaps what it does. It says your name, maybe your student number and the date. So it's exactly the same as doing a title for an essay. You're doing a title for your piece of code because you don't expect that everyone knows what on earth you're doing just from you know, just because they can read your mind, because no one really can read your mind. Okay, and then after your header comment, which we include at the top of every file that we write, we've got our #include tag, and the #include tag is a special tag that we use for our compiler, and what it does is it includes something. So it's like you've headed out to the library and you've borrowed some functions from that library. So if we have a #include, there's a whole bunch of standard libraries that come with C. And those standard libraries have in them things that we can use that we don't have to write the code for ourselves. So things like printing out to our terminal or scanning from our terminal, which we will talk about later as well. All of those things are included in those special libraries. And what that means is that we don't have to write the code for it. We're just borrowing that code. So it's really, it really allows us to, you know, write less code, and also allows us to use this code that's already available. We know it's got no issues. Why wouldn't we use it? It's something that is sort of well known, well out there. And we're going to look at a few different standard libraries that are available to you. But the one that is the most basic one is this standard input-output.h. That's what stdio is, and it really allows you to do input and output. Okay, so when you #include stdio.h on top of your file, you are telling C to take the code from that standard library that you're going to be using it in your code as well. And if you try to compile without it, which we will do in a second, you will see that it will not be able to do it. Oh, my video is in front of the box. I just feel like all I have to do is just keep moving myself around. Apologies. Okay. Okay, then after that, we go into the main function. So C starts reading at the main function. So even if you have, I know you can hear me referring to function, and you're going, what on earth is a function? It's just basically different little pieces of code, and each function or a different piece of code is like a different, it will perform a little bit of the code that you need to do. It just helps us to break things apart, so it's not in a huge 1,000 line essay. It's like a chapter of a book almost. So you're breaking up your book into chapters. So C always starts reading in the main function. So whatever says this main bit, that's where it will go into. And you will always see that each function or each chapter starts with something here, and then it will start with a word here, and then something else in brackets. And what it's doing is it's telling you a few little things when it does that. The main, or the item that you'll see in black when you're doing it in your gedit, is the name of the function. And so every piece of code will have a main. And then your int, the thing that you write at the start, it doesn't have to be an int. What it is saying to us is that the return type will be an integer, and we're going to learn more about the different variable types in this lecture, so you will understand more that you can return different things. So what that's saying is that our function will give us back an integer when it finishes running. And then inside here, you can see this lovely thing, a void. It literally is what it means in English as well in this case. So void is like a space of nothing, and what it means in this case is that you're not taking any inputs into this function, so you don't need anything to run this function with. There are no inputs into it. So the first word is the output, what you get from it, then you get the name of it, and then you get what you input into it. Then you see these lovely curly brackets, okay? And the curly brackets are fairly important in that whatever is between the curly brackets is our piece of code or a set of our program instructions, okay? So what we get is this printf function. This is a function that we borrowed from that standard library that we included at the top of the file. And what printf does is it's able to take whatever is in your apostrophes and it takes it out onto the terminal. You'll see that this lovely /n is here, and we'll talk about that in a second because it's in a different color as well. And then we finish each statement that we make with a semicolon, and this is going to be the bane of your existence. If you write many lines of code, sometimes you'll try to compile, and you will almost certainly always be missing a semicolon. What it will also do is if you go on to write reports after this or any sort of document, you will over litter them with semicolons because you just, get so used to putting semicolons at the end of everything. And then because we've said that our function returns something, this function is going to return a 0, okay? Now, as a standard sort of consistency thing in C, when you return 0, that means that the function has completed successfully and it has run successfully. And so all it's saying is that I'm done, everything finished well, things are going well, okay? And so when you specify something here, a data type, that's when you're going to return something. So don't be confused. I'm about to go to the screen and actually type it out so that you can see what's going on as well, okay? And we'll talk about it soon, so don't worry. We introduce things and then I will go on to type them out as well. So let's have a look at it typed out. So I'm going to switch my screens to my VLab. Okay, so something that and someone asked, can we replace 0 with any integer? You absolutely can. You could have anything in there. As long as it's an integer, but it depends what your function is doing as well, in that what you're going to return. The 0 is something, it doesn't have anything to do with binary. It's just kind of like a standard way to say this has finished successfully, okay? And usually you will return a 1 if it hasn't run successfully. But for now, we will just use 0, and I'll show you how to use or return different things as well. So return 0 just really means it's finished and it's all finished successfully. There were no issues in finishing it. Okay, so I'm going to go inside here and I'm going to start a file called hello.c. I'm going to use my gedit and I'm going to type in gedit to open the editor, and I'm going to give the name of the file. I've called it hello.c. You can call it anything you want. If you're doing a C file, you have to have the .c extension, just like a Word document has a .doc. And then our ampersand, which means that the ampersand means that I will continue to have control of the terminal even after I open my gedit. So as you can see, I can still have control and can still do things in terminal, even though I'm running my gedit simultaneously. So first things first, I'm going to write my header file, and I'm going to say what the program is doing. I'm going to say my name, and perhaps I will even say the date, September 2021. Okay, then the first thing I will usually do is I will hash include some libraries, and in this case, because I want to use a printf, I want to print something out to the terminal, I'm going to use the standard input-output library. Now, if you're wondering why it's printf and not just print, printf just means print formatted, okay? And there are some really strange sort of, ways that we call things. So don't much worry about it, but that's what it, kind of does. Okay, then I'm going to go into my int main void. So I'm creating a main function. And what I've done here is I have the words int, which means I'm returning an int. I've named my function main because that's where I'm starting out. And I'm telling it that there is nothing going into this function. Okay, then in between my curly brackets is where I'm going to write the code. So I want to print out to the library. So I'm going to use the printf function. Okay, now the printf function, inside it, if you put in apostrophes what you would like to actually print out, I think I'll print out hello. Close my apostrophe and don't forget the semicolon. And now I'm going to return 0 to say that, yep, that's probably run successfully. That looks okay. Okay, so what I can do now is I want to try it out to see if it actually does work, or if anything is, or if anything's the matter with this. So if we run it, we're going to use a compiler to run it, because we want to translate what we have in our language C here into a language that the computer can understand. So into ones and zeros, and we want to create a file that we can then run. I haven't included a new line yet, but I will next time. I want to see what it does without the new line, and then I'm going to include a new line after that. Okay, so our compiler is called DCC. So I'm going to call DCC, and then what I will do is I will use this little flag here called -o. And what that flag does, the -o, is it's telling the compiler that I want to name my output something, okay? Otherwise the output has a really yucky name, and it's all the same for everything. So using that -o allows me to tell the compiler that I want to call my output something. And I'm going to call it hello. So what I've told my terminal is that I want to run DCC, which is the name of the compiler. I'm going to use the flag -o to say I want to name my output something. I'm going to name my output hello, and then I've got to tell it obviously what file to compile. And my file is called hello.c, so that's the file that I'm going to compile. So if I run this now, you can see that it's produced absolutely it hasn't given me anything, no errors. So what it means is that it's compiled successfully. Now if you want to see what happens if you do have an error, I'm going to comment out this standard library, and now I'm going to compile it, and if you notice, if I press the up arrow, it's just going to recall the command that I used last. It doesn't mean that I can type that fast. If I run it like that with my standard library commented out, what you will see straight away is that I get an error message, because it actually does not know what printf is without referring to this library that you include. And your warning or your error message is actually telling you what's going on. So it's saying this printf is not recognized. We don't know what on earth it is. And it actually even tells you to include stdio.h. So it's telling you which standard library to include when you're running this piece of code to make it work. So sometimes those error messages are quite useful, and we'll talk more about error messages as we go. Okay, so I've compiled it again, and what I am going to do now is I want to be able to I want to be able to run what my output is to check that it is actually working as I want it to work. Okay, so then to run a piece of code after you have compiled it, you know that you've called the code hello. So to run it, you do a // and then you type the name of the program that you want to run. Okay, so this is what lets us run that program, but it has to be in the current directory. Okay, so if I run it now, you can see that it's printed out this hello with an exclamation mark, which is really neat. But then quite in an aesthetically unpleasing way, what's happened is that it's sitting here with my, everything is happening all at once. So I really want to be able to, I want to be able to put an enter or a new line after this hello to move my terminal prompt to the next line to make it look a lot neater. Oh, my video again is in the way. I wish I could just turn this stupid video, I could just turn the video off. You know what, I'm going to turn the video off just whilst I'm here, because my face is blocking the whole thing, which is, and you want to see the code, not me. So I've just turned my video off whilst I do that. Okay, there we go. It's turned off, so now you can see what's going on. Okay, so we want to be able to move this terminal prompt onto the next line, which means that we really want something to follow that hello. And this is where I'm going to tell this computer to please give me a new line. To do a new line, you do this /n, okay? And that's what tells it, please go to a new line. /n is making it go to a new line. There is other things that you can also do. You know, there's you know, tabs and other breaks that you can install, but the one that we mostly focus on is that we do the /n, which is the new line. So now if I have the /n in there and I recompile my code again, I'm just going to clear this so that it goes back to the top of the line. And what I'm going to do is I'm going to recompile it now. Okay, and it's compiled successfully, no errors. So now I'm going to do ./hello because I have told the compiler to name my output hello. So to name my program hello, and then I'm going to run it. And now it says hello, and as you can see, my terminal prompt has moved to the next line. So what that new line has done is it allowed me to move things around, okay? Okay, so that is a very simple hello world, okay? And I see there's a lot of, you know, a lot of questions being asked, and I know people are, well, Tom and Shrey are doing really well answering all of those questions. So I'm going to, Tom and Shrey, do you have anything to add to hello world? No, okay. Nothing to add. Very good. Okay, so then let's maneuver on.
It's worth noting that this is just a very standard introduction to the code.
Okay.
Sasha, we're a few seconds behind you because we can't hear you in our call currently. But it's just worth noting the in main void, you can just pretty much ignore the syntax for now. And just imagine that when the compiler sees the word main, it sees that, all right, this is where we start reading the code from. Don't worry too much about the specifics for now. Just worry about what's inside the brackets for now.
I'm going to, hang on, I'm going to give you code. I was trying to mute Tom before because he was punching loudly on his keyboard and I forgot to unmute him. Okay, let me...
Mute yourself.
Yeah, well, I muted myself so as not to hear Tom. Okay, let me give you the access to that piece of code. Hang on.
Cool.
Don't take to heart what I'm writing now.
So if you're wondering, this is just making the code accessible to all of you. And you definitely don't need to know about any of the commands.
Yeah, don't look at any of this. Ignore this. Ah, and my bad typing as well. Ignore it.
And DCC-O hello.c, that is just saying, all right, we have a file called hello.c. Hello.c is our human code, right? This is where we write the code that we can understand. When we use the compiler, we need to translate it into code the computer can understand. And so DCC will translate from the hello.c and it will output to hello. So that -o means output to a file named whatever you put after the -o. So in this case, we're saying -o to hello. So we're going to output the translated machine program to hello. Then, when we do /hello, we'll say, okay, now run hello. So you can think of // as run, and you can think of hello as the machine program, which we told DCC to put the machine instructions into.
And it's also worth noting there's a hello.c tilde, so that little squiggly line. That's a backup file which Gedit makes, and you can completely ignore it. You can remove it if you want to. If you want to leave it around, that's fine, but you don't need to worry about it at all.
Yeah, okay. So hopefully you should now be able to see the hello.c. and that's a very simple program that basically, that basically says hello and outputs it to our terminal. Okay, so that was really exciting. You've done something. You've exited to terminal. You've given it a little bit of a terminal. So it'd be good if you guys can try it yourself. And also, what I want you to do is to really practice making mistakes in there. Don't be scared to, return to, see what it does. Return nothing. Leave out return. Try out different permutations and combinations, because you can see what kinds of errors it spits out at you and what it's actually doing. Yeah, so, and yeah. Okay, let's go on. Okay, so now I'm going to talk about a few things, and what I want to do is I want to introduce you to a few concepts. So don't worry if you don't quite understand all of these. This is just a little overview to introduce you to this type of thinking, but it's not yet important that you understand exactly what I'm talking about. So basically, when we're writing these programs, they're not just magically living, in somewhere in fairyland. They are living somewhere in memory of that computer, because if the computer can't remember things, then obviously it can't really do anything for us, because it needs to keep things in memory to actually run things. So the computer memory is actually just a big pile of on and off switches. It's made up of ones and zeros, which is exactly what it is. And those switches are bits. And a bit is the smallest possible unit in computing. So it's a choice between a 0 or a 1. Okay, and that's the smallest choice that you can make in computing. Now, that's a very small piece, really. So what we do is we often collect these together into a bunch, into 8 bits, and that's called a byte. So, always if you're feeling peckish, you want 8 bits, you get a byte. So 8 of these on and off switches give us a byte, and we will talk more about how that actually impacts into memory as we go and as we move through the course as well. So what does this look like? Okay, so there's a few things, and please don't be alarmed by, this don't be alarmed by seeing this diagram as well. It's not, you don't need to understand it right now, but I think sometimes seeing it like that, I don't know, can be nice. So what happens is when we execute code, there are 2 important pieces of hardware that play a part, okay? So I don't know if you guys have heard of RAM, which is your random access memory. So when you run your code, the code loads into the sort of fast data handler. It goes into the RAM, which is like your short-term memory that you have as a person. And what happens is the CPU actually processes the instructions, it performs the basic arithmetic, but the RAM is responsible for keeping track of the data that you need to run that piece of code. And what that data includes is it includes your actual code, instructions, any sort of global variables, and then includes a whole bunch of variables that you create in your code. And those variables might go into something called a stack or a heap. You don't need to worry about it for now, but just know that there are sort of, different places where things can go in memory. And if you've ever heard of the website Stack Overflow, it kind of gets its name from this sort of Stack Overflow business. And so what happens is when we have variables, when we create variables, they get loaded up on here, either stack or the heap. So as you can see, the more variables you have in your program, the more that stack might grow, or the heap. Sometimes they will crash and they will have a bit of an accident, which means you will overflow the computer's memory and there is not enough to go around. And that is something that we will look at as well as we keep going. So don't worry if you are not quite understanding this diagram yet, that's okay. I will keep bringing up this diagram. I just wanted to give you a little bit of a first look at what this diagram looks like. Okay, so what is actually a variable? Now, I would imagine that most of you have done maths at school and you all have done algebra and you all use letters to hold some value that might or might not change over time when you did your functions, and that is kind of a similar way in what a variable is. A variable is something that changes its value over time. It can change its value, it doesn't have to, but it can. And we'll talk about what happens if you do have a variable that doesn't change its value. And each time we have a variable, we use up a little bit of space. Okay, so we use up a certain amount of bits to represent something. And how much space we're using up depends on what kind of variable we have. You know, is it an integer or is it a floating point number? So is it a decimal? What is happening? So each variable will have a different amount of memory that it needs to live. So today we're going to learn about 3 types of variables. We're going to start out with 3 different data types. So they're called data types because they define what kind of data there is stored in that. And what C does is when you have a variable, you say what data type it is, because then when the computer runs your code, it knows how much memory to allocate to a particular variable because of the type that that variable is. So the 3 types of variables are an int, and an int stands for integer. An integer is a whole number, so anything that doesn't have any decimal points, okay? 0, 1, 2, 3, keep counting on and on and on, okay? We will also look at a char, okay? A char is a single character, so it can be something other than letters, and I'll show you all the different things that it can be, but the easiest thing to remember it as is it's just one single character, and a single character we usually associate with something as a simple letter. And then we're going to look at doubles, okay? So a double is a floating point number. And I'm blocking you again. Honestly, I really need to stop blocking things with my face. So a double is a floating point number, and what that means is that it's got a whole bunch of decimals behind it, okay? Now, each of these has a different number of bytes that are allocated in memory once the program is run. And how we write code also depends, you know, on using these in the right ways so that we're not taking up a huge amount of space that we don't need to have, or that we are sort of trying to understand what we actually need from the problem that we're encountering. Okay, so 3 types of variables: ints, chars, and doubles. Let's look a little bit more about on variables and how to work with our variables as well. And you would have seen that int as well when we had the int main void. The int there is saying what data type is to be returned. So when we're returning 0, 0 is an int, and that's the data type that you have returned. So naming our variables is quite important, okay? You have to remember that you're writing your code for, you know, for humans basically. So someone else will come along, and out in industry as well, you're not a single man team or a single woman team. You are writing your code usually as part of a team. Someone else has to be able to come and look at your code. You might leave the job, someone else will come onto the job. And what that means is they need to be able to look at your code and hopefully understand it without, you know, seeing, you know, a Game of Thrones-esque chapter book of, you know, documentation of what that program does. So we really want to have really nice variable names because they make our programs a lot easier to read. So a name should have a quick description of what that variable actually is, okay? So instead of using just single letters, so A, B, C, D, X, Y, use the actual descriptor of what that variable is holding. If it's holding the answer, have it as answer. If it's holding a diameter, have it as, you know, the variable name as diameter. Because what that does is it makes your code easier to read. It means that I don't need to refer to different things to be able to understand what's going on. If someone tells me diameter is equal to 3 instead of b is equal to 3, I'll know straight away diameter, there is a circle somewhere, and this is the diameter of it. Because if I see b is equal to 3, I don't really know what that means. Where does b fit into the whole thing? So we always use lowercase letters to start our variable names, okay? And these are sort of important for style. We always use lowercase letters to start our variable names. And C is also case sensitive. That means if you have answer with a capital W inside it and answer with no capital letters, that's two different variables. Okay, so you have to be a little bit careful with what, you know, with how you are doing it as well. There are also some words that you cannot use as variables, and that is because they are reserved words. So things like return, as you can see that I use return in a function to return some sort of value, and that means I cannot use it because it's already used by C for something else. I can't use int, I can't use double, I can't use char, and so on and so forth, because these are all already taken up they are reserved by something that C does itself as well. If you have multiple words together, you can split those with underscores, okay? So you can say long underscore answer and keep it going as that. So it is okay to have longer variable names when you're writing code, because those longer variable names play an important part in making your code easier to understand, okay? So someone else has to be able to come along and read your code. Someone else has to be able to come along, have a glance at your code and get an idea of what your code is doing. Okay, so let's talk a little bit more about each of these different types of variables that we have just kind of introduced you to. So first of all, we have an integer, and the data type is called an int. Okay, an int is a whole number. It's got no fractions. It's got no decimals, and it most commonly uses 32 bits. That's 4 bytes. Okay. However, you cannot guarantee this. Okay, because on different system and smaller embedded systems, it might use less than 32 bits. So you have to be careful in what you are doing. But if you have those 4 bytes, if you have those 32 bits going, you will have exactly 232 different possible values. The maximum is very large, but it's not infinite. Okay, you will, because you have this restriction in the amount of memory that an integer can take, you also then have a restriction in how many numbers you have. So even though numbers really can go to infinity and beyond, they can't when you are programming, and this can lead to, you know, a lot of issues as well. So what happens is that you can go from, oh my gosh, I'm sorry, see, didn't do superscripts. It should be superscripts, yes. It didn't, I said 2 to the power of 32. So it should be giving us superscripts. But I will fix it in the lecture slide and upload the new lecture slide. So I did it on here, but not on the actual slide. And so here as well, that should be 2 to the power of 31 and then minus 1. Okay. So we've got our integers are going from minus 2 to the power of 31 onwards to 2 to the power of 31 and minus 1. Okay. You don't need to remember this. Okay. You don't need to memorize that that's the range of your integers. But it's important to know that your integers have a range, okay? So there is a limit to how many integers you can specify. Now, does anyone know the reason why it would have a minus 1 here instead of just being more symmetrical? So instead of being from minus 2 to the power of 31 to the power of 2 to the 31? Yeah, so someone has answered it. Yeah, because of the 0. The 0 gives us an extra value that we need to account for. Well done. I didn't mean to go. I need to go forwards. Okay, so let's do characters. Okay, characters are quite funny in C because characters are actually stored as integers. So just to confuse you in this beautiful love story of characters and integers that go hand in hand. Basically, what happens is that in C, characters are in order to represent characters, computer maps each integer with a corresponding character using a numerical code. And that numerical code that is used is Ascii. I don't know if you've ever heard of Ascii. Ascii is the American Standard Code for information interchange. And it kind of came about quite a while ago, bit of trivia, and there is a whole bunch of things in here that really we don't really need anymore, but it still is the way that characters are mapped in C. So if you guys, you can't see because my face is in the way. Again, let me move my face out of the way. There we go. And so what happens is that you have this lovely Ascii table. You can look at it whenever you want. And by typing Ascii in your terminal, I've got a flag here. I've got a -D. What that does is it only gives me the decimal values for the Ascii. So it creates a neater table. If you type Ascii, it will give you the hexadecimal values as well for Ascii. So it's not as, it creates a longer table. But as you can see, each letter of the alphabet is mapped to a number. So a capital A is also mapped to the number 65. So that means when I have a char and that char is a capital A, what it's storing is actually the number 65. So a single character variable, and this is more how, well, I'll talk more about why it does that, I think, in a further lecture, so as not to throw you all off. But it has to do with how our memory works as well. So if you've got a data type char and you're assigning a value to it, you will put that value into single apostrophes, into single quotes rather. And that allows, so what will be stored is the number 97, which is associated with it, but the character for it is A. And you can go between one and another. And, you can sort of pass around whichever way you want to do it. So for a capital letter A, the character is a big A, and the int is stored as 65. But what it allows us to do is, because they're stored as ints, we can actually do maths with our chars, okay? So if we want to go to the next letter, we can just add 1 to that char, and it'll take us to the number 66, or the letter B. And what that means is that, it allows us a little bit of flexibility in how we can play around with the characters. And we can move around the characters by adding or subtracting from them. And I believe the lab next week will allow you to practice that skill as well. Okay, and then the last data type that we will learn about today is called a double. And a double is a floating point number. What it means is it's a decimal value. And that means the decimal point, by floating point, the point can float around and it can be anywhere in the number. So that's all it means, okay? So that decimal place can go anywhere in that number. Now, it's called a double because it is double the memory that an integer holds, okay? So whereas an integer is usually 4 bytes, then we have the double is 8 bytes because it's double that size. And it's worth considering also that your double, even though you can have, infinite number of decimal places, actually computer memory cannot accommodate this infinity to beyond and beyond sort of aspect. So you will get some issues based on that we will talk about in a second. There are many more data types in C, Okay, but those are the three that we're starting with today. But there are many more data types because you need to be able to do a whole bunch of things, and to do a whole bunch of things, you need to have more data types as well. So if we look at how we're going to declare variables and initialize them, so when we talk about variables, we need to be able to tell the computer that we need a variable, so we need some space for a variable, that means, and we also can initialize it by giving it an initial value as well. So if we have a function and we want to declare a variable to start with, what we do in C is we tell our computer what data type we want that variable to be. And then we give that variable a name. So when this program is run, C knows straight away how much memory it needs to allocate to this variable because it knows what data type this variable is. So let's say we have an int answer. What that means is that we have just created a variable called answer, and it is of type int. Okay. After that, what we can do is we can give that variable a value, and that's called initializing it. So when we initialize it, we're giving it its first value, or we're giving it its initial value. We no longer need to specify what data type it is because we've already specified what data type it is here, and we can refer to it by name. So we just say answer is equal to 42 and finish it with a semicolon. And what that does is it assigns the number 42 to that variable. Now, one thing that is worth to note is this equal sign here. You guys are used to coming from maths and doing maths for a long time. You're used to the equal sign meaning equal to. Now, in this case, one equal sign does not mean equal to. It means that I have assigned a value to something. So what happens when you assign a value is you look up here on the right hand side and you see the value's 42 and you assign it to the left hand side, which is the variable answer. And equality is set in a different way in C, which we will look at today as well. Okay, and then you can change the name of that variable as well if you like. So I can call the name of this variable again, answer, and I can assign the number 7 to it. So now this variable holds the number 7. Now when you get, all cool and excited, you can also do it all in one line. You can declare and initialize a variable together. So I can say straight away, I've got a data type int, so something is of type integer. It is going to be called answer2, and I'm going to assign the number 88 to it. So I can do it all in one go. I don't need to do it over 2 lines. I can do it all together as well. And if you notice that the names of the variables, again, they are in small letters and they are also describing what we're getting here as well. So we're getting an answer. Okay, what we can do is it's great to have a variable, but what can we do with our variables? Okay, we can do many things with our variables. Obviously, we can do some maths with them. We can print them out. We can do a whole bunch of things with them. Now, printing out to terminal, we can print them out using that printf that you have only just used, and you have used it to print out just a sentence, but you can actually also print out certain variable names. So it's not just for specific messages, it also allows you to print out variables as well. If you want to print out a variable, you use something called a format specifier, okay? And there's one for each one of our different data types, so you can use a different one. So as you can see, I've got a variable here. The variable name is number, it's of type integer, and I've assigned the number 13 to it. And now if I want to print it out, then I'm going to use the printf function, and I'm going to say my number is, I can say anything I want before it. But to actually make it display the number, I'm going to use this %d. And when you use this % symbol followed by some characters, you're letting the compiler know what data type you actually wanted to print. So in this case, you wanted to print a decimal value, okay, which is why you're writing %d. And then you put a comma and you write down what the name of the variable is to finish it out. So in my case, the variable name is number. And then as before, I'll close a bracket and I'll do a semicolon to finish my statement. And what this will do is it will print out the number. And we will put all of this together in code after these slides. Don't worry. We're just going over it now and then we will do it in practice as well. What's happened here? I'm missing an image. This is very annoying. I'll show you how to do this in code. But basically what I was trying to say here is that the variables will match the symbols in the same order as they appear. So what it means, you can have 3 %ds in any one line, and then you can just have 3 variable names, and it's all on the order that they're listed. That's the order in which they will appear. So for example here actually, you can see there's 2 different variable names and there's 2 different variable names here. Okay, so that was a %d, so that was just your normal integer. But now let's say we want to print out a double. So for a double, we use a %lf, okay? And the LF stands for long floating point number, okay? So if you use LF, then you're going to get a decimal printed out, okay? So remember that we have to be very prescriptive when we tell the computer what to do. And that, that extends to telling it what data types we're going to be printing out in C as well. So in this case, I have a data type of int. It's called diameter, so that's my variable. And I've assigned the number 5 to the value of diameter, to the variable diameter. And I also have a data type double, and that means it's going to be a decimal. I've given it the name pi, this variable, and I've given it a value as well. And so now when I print them out, then I can specify that 1 is a %d, so 1, the diameter is a decimal value, whereas the pi value is a decimal, so it's a long floating number. And then in the same order that they appear in my text, so %d, %lf, that's in the same order that I will use the variable names after my printf to type out. Okay, so what about a char? And I've left the char to the end because the char has a few little specific things going for it. Because a char can also be a lovely int, it can be expressed both ways with a %c or a %d, okay? So it can either be printed as a character with using a %c, or it can be printed out as the number that it indexes to on the Ascii table, so as a %d. So for example, let's say I have a data type char, and I've called my variable letter, and then I've assigned the letter A, capital letter A, so I've put it in single quotes to assign it to the variable letter. So then if I'm going to print out, I've printed out here the letter %c has the ASCII value of %d. What this will print out for me, and if you notice here, I've referred to it, if I've got 2 format specifiers, then I need 2 different variable names here. But as you can see, the variable name is the same. The first time, that variable name is going to print out a capital A for me because that's what I've assigned to it. And the second time, it's going to print out the index that the letter is actually, that it indexes to on the Ascii table. So your character can be both a %c and a %d, depending on what it is you're trying to do or you're trying to see in your code as well. So characters are quite tricky in that way. Okay, so that's fantastic. We've done, we can print out to our terminal. That's great. what do we do now? It would be useful to also scan in from terminal. So it would be useful to take some input from the user, wouldn't it? It would be useful to know perhaps to change up what those variables are and what the user can do. So there is also a function inside that standard input-output library called Scanf. So there's Printf, which prints out to terminal, and there's Scanf, which picks something up from terminal. So it allows us to take in something that the user will specify to us. Okay. So if we read an input from the terminal, we also use the same format specifiers depending on what input we want to take in, okay? So either it's going to be a %d, a %lf for a decimal, or it's going to be a %c for a char. The same way that in printf we specify what data type we want to print out, in scanf we specify what data type we want to scan in. So as you can see, I'm declaring a variable. The variable data type is int, and the variable name is input. And then I'm going to give a prompt to the user. So please type in a number. This is going to then allow the user to type something in, and for me to take that number and store it in some sort of variable. So I've created this variable here called input, okay? And that's where I want to store the input that the user gives me. So what I do is I use the function scanf, and I specify in apostrophes here that I'm going to scan in a decimal number. So I'm scanning in a %d. And then I'm going to put a comma, and the same way as in printf we specify what variable name we're printing, I'm going to specify what variable I'm storing it into, okay? I'm storing it in a variable name called input. Now you'll notice that when you use scanf as well, you have this lovely ampersand here. The ampersand is very important in the scanf function, okay? You will have to put an ampersand, you will have to put it in front of every variable that you're scanning into. What the ampersand symbol means is that it means go to the address of that variable and put my variable in there that I've just scanned in, okay? So if you guys remember, when we create this variable name input, it goes somewhere in memory, somewhere, I don't know where it's gone. So when I'm scanning something in, I kind of need to know not just the variable name, but I need to know where on earth can I find this variable to put this value into it. So all that you're doing with that ampersand is you are telling the computer, please find where this variable is located and plop whatever was entered in here into this variable, okay? Now we're going to learn a lot more about that ampersand and the address of and traveling to the address of our variables later on in the course. But for now, just know that when you're doing a scanf, it's not enough to just put in the name of the variable. You need to tell it to travel to the address of that variable. So you always need to have this ampersand there. Okay, and then similarly, if you want to read a double, you will declare a double data type and you'll give it a variable name. Again, I might type in a prompt for my user, and then what I'll do is I'll scan in, but this time I'm going to scan in a %lf. So I'm scanning in a decimal point, and you notice again I've got the ampersand here in front of my variable name, and that means that we're going to that and putting the variable in there. Oh, someone's asked a really good question in the chat. How come we can get away without using the ampersand for printf? So that's a really great question, and the reason for that, there you go, Shrey's saying to treat it as magic for now. But yeah, it's because Tom's just answered it. It's because when we're doing scanf, we actually want to put a value into that variable. Whereas if we're printing it out, we know what the value is. We're not changing anything. We're literally just saying print out whatever it is. But yeah, more details coming. Don't worry. We're not going to leave you hanging. Okay, the lovely Char, our poor little Char. So if you want to scan F, or if you want to read in a character, you'll need to declare that character by using the keyword char, okay? So even though it's still stored as an ASCII value, when you printf that variable or whatever else, you need to declare it as a char for scanf to be able to read it if you want to scan in a letter or a character. Okay, what if a variable never changes? Well, I mean, if it never changes, it's not really a variable then, is it? If it never changes, it's probably going to be a constant. So if you have something that never changes throughout the course of your program, you're better off putting it as a hash define, okay? Now a hash define usually goes just after our hash include, and we usually name our hash defines with capital letters. So you can see if I hash define anything, I'm going to use capital letters, because then when I use it in my code by referring to it with this name, I will know that I am actually talking about using a hash define that's listed at the top. So it's a style guide that lets us remember that it's not a variable, it is actually a constant, okay? So what we do is we hash define, we write the name of whatever we want that constant to be, and then we give it a value of what value we want it to take. And we will be putting all of that into practice. So okay, so let's quickly talk about some maths. We're heading towards a little break. There's only a few more slides, okay, to go before break time. Sorry, I have run a little bit over. I'm still getting the hang of timing for these lectures. Sorry, this is the first time I'm giving this lot of lectures, so I'm still kind of understanding where timing is going. Okay, so let's talk about some maths, okay? So there are some quirks sometimes with maths and in C, and that's because we don't have an infinite space for our numbers, and that's usually where the quirks arise. But you can do some very basic maths. You can do some very basic maths with C, and it looks very familiar as to what we're used to doing, you know, everywhere else. So we can add by using plus, we can subtract by using minus, we can multiply by using a multiply, and we can divide by using our dividing bar. And these happen in their normal mathematical order as well, or we can use brackets the same way as we do in maths to force some sort of precedence, you know, to force something to happen before something, you know, before something else. So for example, if I have a variable x of data type int, I assign it the value 5. I have a data type int variable named y, and I assign it the value 10, and then I have a variable named result, and it's of data type int. I can say that result is equal to, and I can use brackets to force it to do the addition first. So it'll do the 5 plus 10 first, it will be 15, and then it will multiply it by 5. And then I can print it out, and I can print out my result in here by using the %d specifier as well. So maths is basic, but you can do a lot of things, follows very similar rules. And remember that you can also do maths with your char, because they're just like ints, really. So what happens in this case is that we can actually move around our letters. We can add 1, or we can subtract 1, or we can add, you know, 10, and it's going to move us around based on where we are in that Ascii table. And we will play around more with our chars as we go as well. So, but this is, you know, a little piece of code that you can, you know, even put into your gedit to try as well. Okay, so there are some quirks to integers, and it's because sorry guys, we will do a demonstration soon. So the quirks occur because we have integer overflow or integer underflow. What happens is that there is not enough memory space to keep all this infinity and beyond exercises, infinity and beyond numbers. So our numbers are kind of limited. So I've put in a few links. If you're interested, you can have a read about what can happen if you do an integer overflow or an integer underflow. So you've got a nice plane that has to be rebooted every 248 days. And that happens because of an integer overflow issues. What happens as well is if we add two very large integers together, we might go over the maximum value. And what it does, it rolls back around to the minimum value. It can also end up negative, and you can check out this area in 5 explosion, where a simple error like that led to a huge problem. And I've put a link in a less destructive example. If any of you know the video Gangnam Style, it maxed out on YouTube, so it maxed out the views counter. So that's another example of that integer being overflowed. Yeah, and so, and the other thing as well, you know, ints might not always be 32 bits. It's really dependent on the operating system and what's happening. So that's another thing to consider. So that can also, you know, that can also stuff up what's going on. But the best way is to just make mistakes. Don't be scared to make mistakes. It's really, if you have a question, you know, about what will this do or what will that do, just try it out. You know, you can't really, you know, it's so much fun trying things out, and it's even more fun breaking things. I love breaking things. And then doubles as well. So again, there's no such thing as infinite precision because you are limited in how much memory space a double can take. So you can't do, you know, these repeated fractions. If you divide 1 by 3, you're not going to get 1.33333333. You're going to taper off sometime. So if you keep, you know, if you keep approximating and you keep adding things or subtracting things and keep going with these repeated numbers, you're going to get some serious carry errors as well. So it's kind of like it's always an approximation. So in C, C thinks in data types, okay? So things are either an int or they are a double or they are something else, depending what data types you're using. So the way C operates is that if both numbers are ints, the result will be an int. So if you're dividing 3 by 2, it will not give you 1.5 because 1.5 is a double. What it will give you is it will give you 1 because that's what the int is of that division, okay? So if you're dividing 2 doubles, then the result will be a double as well. But if you have 2 ints and you're dividing them, you will drop whatever fraction or whatever remainder exists, okay? And that's why we have a really cool thing called the modulus, and it's the percentage symbol. If you use this symbol between 2 numbers, it will give you the remainder from a division between integers. So for example, 5 divided by 3 will return you 1, but if you do 5 modulus 3, it will give you 2, because 5 divided by 3 is equal to 1 with the remainder of 2, and that's what the modulus symbol is doing. It's giving you whatever the value is of the remainder. All right, let's take a quick break right now. Let's take, oh gosh, a 5-minute break or a few minutes break, 5 minutes let's do, and then we'll come back and we will talk about if statements, and then I would like to do some coding as well. All right. Hello, everyone. I saw someone, solving the riddle properly, so that's quite nice. And also some pretty fun solutions in there. Love it. Okay, so what we're going to do is, I'm sorry my timing's been a little bit off. I am going to fix my timing, and what I'm going to do is I'm going to go into a demo now to demo all the things that we've talked about, because I think that's a little bit more valuable. And so my usual style of lecture coding is doing a bit of a loose unit. I like to demo everything, but I've tried to try the slides more this time, and it hasn't quite worked as well as I hoped for. So let's go demo. Why not? Let's have fun. So let me switch on VLab. All right. Okay, so let's have a look at different things, and we will talk about all the different things that are happening. Okay, so I'll go back here. So that was hello.c. So maybe let's do a different file that we can use. Maybe if I spell it correctly, I'm going to call the file variables.c, and I'll use my ampersand to maintain control of the terminal. Okay, so let's talk about variables. Okay, so the first thing I do is I include my standard input-output library, and then I start to do my lovely int main void, which you guys will become very well acquainted with doing. And then whatever goes inside my curly brackets is my piece of code. So the first thing I'll do is I'll kind of work on I'll work basically with just ints and doubles just to show you what I'm doing, and then we will do some char examples as well in code. Let me just move my face off the screen so you can see things better. And you know what I'll do? I'll go like that, and then that's not in the way as much. Okay, fantastic. So now I've moved my video over, so it shouldn't be blocking anything now. Okay, so let's do some declarations and some initialization of variables. So what you'll see me do is in the lectures, I will comment the code way too much. That is not what you need to do when you're writing a piece of code. You will not need to comment on every single variable that you make to tell us what is going on, okay? Because your variable names should be descriptively enough named that you do not need to do that. But in the lecture, what I will do is I will comment everything just so that you can see what I'm doing. So let's talk, caps lock on, let's talk about declaring a variable. Or even many variables. So let's first declare an int. So when we declare a variable, we always have to specify the data type of the variable. And let's say I'm going to do an int, and I'm going to call it answer. So what happens now is that I have a variable called answer, and it's of data type int. So what it means is that inside it, I can place any type of number, okay? And when I assign a number, I say my variable name, and I use the assignment operator, which is just one equal sign. It means assign to. So let's say answer is equal to 13. What that now means is that answer variable has the number 13 in it. Now, if I want to see it, perhaps I'm going to print it out to my terminal. And I'm going to use a format specifier %d to tell my computer that I'm going to take out a variable, and then I'm going to also do a new line just so that it looks neat for no other reason. I will place a comma and I will write down the variable name that I want. close the bracket, and I will use a semicolon, and I will return 0 to say my program has just finished. So you can either do, when you're declaring the variable, I've done it in 2 lines, you can do it like that. It's the same thing to also do it all in one go. So you can also do it like this, and then you don't need the second line. And it's, you know, up to you how you are doing it, as long as you, so you can declare and you can also initialize on the same line. So now if we run this, what I expect is for it to be able to print out the answer is, and then print out the number 13. So let's see. So DCC for my compiler, I'm going to name the file variables, and the name of the file that I'm compiling is variables.c. Now if I run it, everything seems to be okay. So I'll clear the terminal, and I'm going to do /variables because that was the name of my program. And when I output it out, it tells me the answer is 13. So I was able to print out, and I was able to have a variable, and I was able to assign a number to that variable. Now I can also choose to change the value of this variable at any stage, okay? And C runs code starting from the top and going down, 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 line by line. Unless, of course, you have conditional statements, in which case it will skip some sections of code, but we'll talk about that. So if I've got int answer, at this point over here, it's equal to 13, but when I do answer is equal to 1 here, at this point in time, it's now equal to 1. So if I compile it again, okay, and then I run it again, well, as you can see, it's given me the same answer, okay? And you'd be wondering, why on earth is it? I've just said that answer should be equal to 1. When you're using gedit, have a look up here. If you see a star next to your file name, what that means is you have not saved your file, so it hasn't updated it, okay? So save the file first, then compile it, and then run it. And once you do that, it will actually give you the correct answer. So the answer is 1. So we were able to change our answer as we go. Now, we might also have a second answer, okay? Let's say I want to have another variable called answer2, and this variable I'm going to make equal to 7. And what I want to do is I want to print out both of them. So I'm going to say the answer is %d, so the answer, that's the first one. And then I'm going to say the second one. So the answer 2 is, and then I'm going to have a %d for my second answer. So the first variable name applies to the first format specifier, and then the second one I need for the second format specifier, so for the second %d. So let's say I've got my answer 2. So now I'm going to be printing out 2 variables. I'm going to save it, I'm going to compile it again, and then I'm going to run it again. Okay, and this time it's going to give me the answer is 1, which is my first variable, and then the answer 2 is 7, which is my second variable. So I was able, and I can have as many of these as I want in my printf statement, okay? And I can have as many here as I want as well. Okay, so let's have a look. How am I writing the commands so quickly? Well, what you didn't know is that I'm a superhero who can type so fast. No, it's not true. I'm pressing the up arrow. If you press the up arrow in terminal, what it does is it brings up all your commands that you've typed in the past. Okay? And how can you change directory in the terminal? You press CD and what directory you want to change to. Okay, so that's using those variables, and what about now, let's have a look if we have a double in there as well, because that will be neat as well. We want to be able to see a double as well. It's not just ints that we care about. So let's say our answer 2 right now is going to be not an int, but it's going to be a double. Okay, that means that my answer 2 is now going to be a decimal. So let me make it a decimal. I'll say it's 7.3. Okay, so do you guys think that everything is fine and it will compile perfectly now? Or will I get an error? What do you reckon? So I've got my 2 variables here and I'm printing out 2 variables. So what happens if I compile it now? Do you reckon there will be an error? No, everyone reckons it'll go, oh, someone's got it. Yes, I will get an error, absolutely, because that's right, everyone's got it, well done. Because my format specifier here is still that I'm going to type out a decimal number. But in fact, what I have is I have a long float. I have an LF, I have a decimal number. And as you can see, my error message is actually telling me that. So my format specifies type int, but the argument has type double. And it's even suggesting for me to change that. So I need to have an LF here for it to be able to print that out. Otherwise, it doesn't really make much sense. So now if I compile it again, and if I run it again, now it will be able to print it out for me, no problem. Now what you can see here is that double also puts a whole bunch of decimal places for me there as well, okay? So there are ways that you can, cut that. You can make it to however many decimal places you want it to be. Does anyone know how to do it so that it looks much neater? Oh, very close. So we've got someone in the chat suggesting if we just do 2LF and that will be able to cut it down for us. So if you think that that could be a good thing to do, let's try it out. Let's see what it says. And that's one of the best ways to do it is, oh, it's run. And then what happens if I run my program? Nope, nothing has happened. So the only thing that's missing there is a .2. And let's compile it again and we'll run it again. And now it's cut it down to 2 decimal places. So you are saying it exactly as you would do. So I want to cut it to 2 decimal places. So I'm saying decimal place, 2 decimal places. And that tells my computer that I want to print it to 2 decimal places. So that was a really good guess, very close. And that can be really anything that you want it to be, however many, you can do .1 as well. But I use .2 because that's what someone had suggested in the chat. Okay, so that's my printing out of integers and doubles. How does everyone feel about integers and doubles? Is everyone super excited by the party that are integers and doubles? Yeah, that's a very good question as well in there. Yes, if you have 0 decimal places, it will also cut it off. That's right. And again, if ever in doubt, try out different things. It's such a great way to learn when you try out different things because it really kind of lets you see what's going on. So I've said I wanted to 0 decimal places and boom, 0 decimal places. Okay, there is, I'll let Shrey answer it. There is a percentage float as well, but we don't use it. We use the percentage LF in the course. Okay, so that's your integers and your doubles. How about we look at our characters now and play around with our characters? Okay, so what I'm going to do is I'm going to comment out this section that we've just done. And if you remember, I kind of showed you can do dash star, and at the end of something I can do another star dash. And what it does, it just comments out a whole bunch of sections. So it doesn't mean, it just means that I don't have to do 2 slashes on every line, which is a bit painful. And I'm going to, I might just move this out of the way, okay? And I'll move it back in just so that it doesn't interrupt us. Okay, so let's have a look at characters, okay? So you can display the Ascii table, and you don't actually need to know the Ascii table, okay? But it's useful when you're learning about chars just to be able to have a look at the Ascii table so that you can see what it's doing. But you don't actually ever really need to remember what number stands for what letter, because that defeats really the purpose of how easy, you know, it can all be. Ah, what a mess. So if I type in Ascii Flag, so apostrophe D, what it does is it shows me my Ascii table. Let me just make it neater. Sorry, I've increased all the fonts, and so now nothing quite fits on my screens. But I kind of okay, here we go. We've got a nice, neat table. So if you want to type in to have a look at the table, just type Ascii and then hyphen D. And that allows you to see all the different Ascii combinations. So what we get is we've got our lovely letters here, and I can't highlight because I can't highlight in row because it highlights columns. But let's have a look at this one here. So let's have a look with a capital A. Okay, so let's say I'm going to declare a character. So I'm going to use the data type char, and I'm going to call I'm going to call it letter, the variable, and I'm going to assign the value A to it. Now remember, when you're assigning a character, you have to use these single quotation marks, because the single quotation marks tell it that you want to assign this character to it. And what happens is that you, so then what is also there is that it is the number 65, okay? Because the letter A indexes to the number 65 on the Ascii table. So what I can do is I can print out that letter, and I can print it out as a character, or I can print it out also as a decimal number that it indexes to, okay? So if I want to print it out as the character, or if I want to print it out as the A, I'm going to use the %C specifier, because that stands for character. And then I might want to see the ASCII value as well, okay? In which case I want to use %D. And I'm going to finish it with a new line because it makes it look neater. Now both times, okay, both times the variable name that I'm referring to is letter. So it doesn't matter that the letter is, you know, it's a character, because it's also an int. So now if I run this, okay, it should give me that the letter is A and the number is 65. So if I compile it, what have I forgotten? I've made an error. I've forgotten a semicolon. This is what nightmares are made of. You will be dreaming of semicolons. So let's try that again. So I fixed that, added the semicolon. I'm compiling it again, and I'm going to run it now as well. So it should give me that the letter is A and the number is 65. So the letter A has the ASCII value of 65. So there we go. So what you get is that my char, even though I've done my variable and I've assigned the letter A to it, it's still also storing the ASCII index of it, so the number 65. So each character has in it the character itself, but also the index to that character. What it means is that I can move around my letters as well. Okay, so I can do some maths. I can move backwards and forwards in my letters. Okay, so should we move around? Why not? Let's move around. Okay, so if we're going to move around our letters, okay, then let's have a look how we do that. Okay, so we've got our letter A, and let's say I'm going to now, how many should we move down? I don't know, what should we do? Let's move down to the next one, just for fun. So I'll go another data type char, and I'm going to do, that's a terrible name actually, I'm going to do next letter. And what I will say that my next letter is going to be is letter +1. So now let's see what happens, okay? So then if I print out the letter %C has the ASCII value of %D, that will give me what my initial letter is. And then I might do the next lot. So the next letter, %C, which will give me the letter, and then I'll have the ASCII value of the next letter. And you can see that you can actually do some very simple maths with your letters because they are also ints. So I've got the letter for the first lot, and then my variable names of the next one is next letter and next letter again. So if I save that now and I run it again, so I'll compile it first because I've made changes to it, and then I'll run it again, and what I'll get is the letter A has the ASCII value of 65, which is what we saw to start with, and then the next letter B has the ASCII value of 66. So I'm able to move around the alphabet just by adding 1. And Becky, you've asked a great question. You can absolutely do single quotation A+1 because it grabs the index from it. Basically, those single quotation marks mean that it's from the Ascii table kind of thing. So definitely, absolutely. So, and why not? Let's try it out. So I can do, let's do, what letter should we do? Where would you like to move? I'm going to use S, and I'm going to add 3 to it. And then let's print that out. I might do a new printf statement so it doesn't look as confusing. And I'll use %C to see what the letter is. And we're using secret letter. How exciting. And what am I missing? Yes, the semicolon. So now if I run it again, I've got my secret letter is V because V comes 3 letters after S. So 1, 2, 3, and I've got my V from my S, which is 83 plus 3 is 86. Amazing. And my basic maths is pretty good too, so that's always good to know. And you can do other characters as well. As you can see, it's not just letters. A char can also have these wonderful things here, exclamation mark, hashtag, percentage symbol, and there is all sorts of little cool things. I mean, this one here, I've always loved the bell. It's from like old school typewriters too. It lets out a little ding. You won't hear the ding because it's on CC machines. You're right, you're running a virtual lab, but it lets out this really terrible like ding. That was a terrible ding, but that's what it does. Yeah, and there's all sorts of fun things as well that you can look up what the whole Ascii table is really. Okay, so that's playing around with letters and also playing around with numbers as well. So now let's look at a little bit of maths just so that you get a feel for maths, and then we'll also talk about that lovely hash define as well. So let me move this slightly out of the way. Okay, and we've got 15 minutes to go, which is exciting. Not exciting. Sorry, I have run over time today. Okay, so let's, that was variables. Let's do some maths, I think. So I might do a new file again. And I will tidy up these files also so that they don't look so messy when you look at them after the lecture. Okay, so the first thing, we're going to include our standard library. And then I'm going to have my main function. All right, let's do some maths. Okay, so let's have a look at, I don't know, let's do two variables and we might do some adding, subtracting, and so on with them. And then we'll look at some of the issues that happen. So let's have the first one, so number 1. And I don't know, I might make it 5. And let's have the second one. And I don't know, I might make it 10, which were the examples that were used in the lecture slides, just so that it, and then I might have something called int result, which is where I want to assign the result to. So if I then say result, and I'm going to use the equal sign to say assign to, and then we can do a whole bunch of different operations. So if I do number 1 plus number 2, obviously that's going to add them together. And if I do multiplied by number 1, what it's going to do is it's going to multiply by number 1. In the current circumstances, just like maths, it's going to do the multiplication first. So it's going to do number 2 times number 1 first, and then it's going to add this number 1. And then what it will do is it'll assign the final answer to result. If I want to force it to do the addition first, I just use brackets, just like we normally do in any maths that we do. And then if you want to print out your result, you can just print out the result. So you can do printf. And if I want to actually, have that sort of, actual math sentence there, you can do your %d plus, %d, and it's equal to, and then times by %d, and it's equal to %d. My goodness, how much is happening in this one? Okay, and then really it's going to be using all of these. So number 1, number 2. So the first one is number 1. The second one is number 2. The third thing I want is number 1 again. So you see how you can have as many things as you want in there. And then the last thing I want to finish off with is the result. So then if I save that and compile it, okay, so now if I compile it, and then run it, what I get is this wonderful 5 plus 10 times 5, and it's equal to 75. Again, you can see the terminal prompt is also on the line, which means that I could just have a new line here just to make it, look more pleasant as well. And if I do that, it'll move the terminal prompt onto the next line. So then it will give me out the equation. Okay. So let's have a look. Okay, so let's say also that always want my number 1 to be 5, okay? It never changes, okay? I've never changed it. Actually, I've never changed it in this piece of code, so it's highly likely that this number is actually a constant, okay? And in that case, what I can do is I can use the hash define to do it. So in that case, I'll use my hash define, and let's say I'm going to call it still number 1 or number. And if you notice, when I do a hash define, then the variable name or the constant name is going to be in capital letters, and it's part of the style guide that we use so that you know that it's a hash defined number. It's not just a normal number. So I've defined my number, and you can have as many hash defines as you want. So anything that doesn't change should really be a hash define. So now anywhere where there was number 1, what I can do is I can refer to it by using this number that I've hash defined, and it will do the same thing for me. But what it allows to do is it allows for your code to be a lot neater, because you don't actually need to have a variable if something doesn't change. If something is a constant, it doesn't need to be a variable. So it's a lot neater to make it a hash define or a constant. Okay, so then if we run it again and we compile it, you get the same thing even though you used a hash define instead, okay? And the reason we use these hash defines, they really need to be outside of that int main, because if you have more than one function, which we will later on, what happens is they need to all have access to this constant, and for them to all have access to it, it needs to happen outside of these curly brackets. So the curly brackets are like the gatekeepers of where the variables live, and we'll talk more about that later. So what that means is this number 2 only lives in these curly brackets. It doesn't live outside of it, and if I have anywhere else in this piece of code, then it's not going to live anywhere else either. So you really want to have a hash define outside of your main. Okay, so let's, I think there's someone, so for now, someone asked about the advantages of constants. For now, really, you need to understand that if something is not varying, it's not a variable, it's a constant. Constants cannot change, okay? That's useful to you if if you do a very complicated piece of code. If you have a lot of variables, there's a lot of potential for them to actually change, and someone to come in and inadvertently change a variable that you do not want changed, okay? So when you hash define it, when you make it a constant, what you're saying is, this is something that we don't want changed. So if someone comes in and looks at your code, they know that they might not inadvertently change it, because it will not allow you to change that sort of constant. So that is, sort of a very useful way that we look at constants. Okay, so let's have a look. Okay, I wanted to start talking about if statements today. Okay, so if we talk about if statements, okay, what do you guys know about if statements? Do you know anything about if statements? Have you heard of if statements? So if statements are these wonderful things that we use to tell the computer where to go and what to do. And if statements, we use them when in problems where we need to make a decision. So anytime where you have to ask a question and answer it, it means that we really want to use an if statement. So if something happens, then we kind of really, we want to do this. Else, if something else happens, we want to do that. Maybe another else, we want to do something else. You really don't want to have, huge ifs, but yeah, people are saying they've used them in Excel, and they are basically conditions, okay? So what that means is that you're able to decide what to do based on what's going on in your code. So it means that your program can branch out between different sets of instructions. And if statements, they solve decision problems. So let's open a new file and we'll do just a brief intro. Okay, so let's say I want to make some decisions in my lovely code. So if statements in code. So whenever you need to ask, is a number even? Is a number larger than 10? Is the number prime? Those are really good contenders for using if statements, okay? And then you might say, okay, if the answer is no, then I might add an else. Or if the answer is, is no again, I might add an else if. So it kind of takes the format where you will have your if, and then you will ask some sort of question in here, okay? So question in layman terms, or it's called a condition. So some sort of condition has to be met. Now this is not code over here, question condition. This is just me kind of writing what needs to happen. Now if the answer to this question is yes, then what will happen is you will go into this little curly brackets here, and you're going to do whatever the code is. So you're going to run that code if that condition is true. What you can then do, if the answer is no, you can tell the computer to run a different piece of code. So if the answer to the first question is no, to the question that we asked here, then the computer will switch to this branch, and it will do whatever is inside the else little bracket. You can add more branches as well if you want. You can do an else if, and you can have another condition in here, and then you can finish with an else. So you can have any number of combinations. You can chain them together, and you can create a lot of options when you're doing your if statements. And it really depends on what you're trying to do. So for example, let's have two integers. Let's do something very simple with an if statement. So let's have int number 1 is 5, and we'll have int number 2 is 10. Okay, what question can we ask? We've got all of our maths operators, so we can really do a lot of question asking. We can use, less than or greater than. We can use a whole bunch of things to compare what's going on. So for example, I might want to compare number 1 and number 2. I want to ask, is number 1 greater than number 2? So is number 1 greater than number 2? So I might type in here to ask this condition. If number 1 is greater than number 2, then what's going to happen? Okay, I don't know, maybe we can print out, let's print out then that and instead of those specifiers, I've got number 1 and number 2. Okay, I'm going to get rid of else if for now because I've just got one statement, okay? Now, I've deleted a bracket, sorry. Or actually, so I can have if number 1 is greater than number 2, then I'm going to print out that it's greater. Or else, I'm going to print out that number, well, what are the different, I guess they could be equal as well, can't they? But let's just print out they're not. It's not equal, just to show you the simplest way to branch it. Okay, so we've got a simple piece of code now that basically says, I want to ask the question, is number 1 greater than number 2? Okay, and what's going to be my answer? Is it going to be true? Is 5 greater than 10 here? No, it's not. So because the answer to this is going to be no, it should go inside my else, okay? So it should really head in here, and it should give me this statement, %d is not greater than %d, so it should say 5 is not greater than 10. Okay, so let's have a look what it does. So let's compile it first. No errors, yay. So then we'll run it. And it's telling me 5 is not greater than 10. So that's good. That has allowed me to, be able to do some basic comparison. What are some other things that I can ask? Well, I can also check if they're equal to each other, can't I? So perhaps I can say else if, and then I can have another condition here where it checks whether they're equal to each other. So else if number 1, and to check equivalence, and this is where we'll do that, where we talk about 1 equal sign being a sign, and 2 equal sign is to test for equivalence. So we'll use 2 equal signs to test for the actual, whether they're equal to each other. We will ask if number 1 is greater than number 2. Sorry, if number 1 is equal to number 2. And then in this case, I will write that they're equal to each other. So I might type in a statement, printf %d is equal to %d. And again, I might have my number 1 here and number 2. And obviously it's not going to branch out to here because they're not equal to each other. But if they were equal to each other, if I were to change that to say that they're equal, then it should print out for me now that those two are actually equal. So if I run it now, then it's going to give me that 5 is equal to 5. Okay, so it's 2 o'clock. So what we'll do is we'll finish there for today. I'm sorry about the timing today. I will do better timing next week. I've kind of got a bit more of a feel, and we're going to focus more a bit on the demos next week as well. Thank you so much for your patience and for tuning in. Appreciate it. And we will talk more about if statements as well next week, and we'll really kind of talk more about everything that's going on. And if you've noticed also, you can see that I've been indenting. You can't see it very nicely because my fonts are so big, so it's curling everything around. But I keep indenting things, and the reason for that is it's got to do really with style. It makes the code easier to read for the person. So that's always very important. So we'll reconvene on Tuesday and we'll talk a lot more about what's going on. So have a really wonderful rest of the week, and I'll see you next week. Bye, guys.